Hello everyone, welcome to another Watch Me Do Math video. This video is a bit different because there will be no video content. It's an audio-only publication. You are safe to move to another tab while listening to this. In this video I'm going to be talking about reasons behind doing maths and how people can actually improve at maths, or at least my personal opinion on the best ways to improve at maths. So, to begin, why do maths? It stops being super relevant to real life around year 8 and 9, so why do it? Maths can be considered a kind of sport. You can continue doing it just for fun, even if it seems to you that maths has lost its practical application, right? It can be considered that kind of sport, or alternatively, it can be considered a kind of tool in a scientist's toolbox, like any other skill that a person can become good at or can train in. Maths does not even lose its application to real life at that level as far as one might think initially, because there are always ways that you can apply new maths up until you get to the real sort of monks sitting on a mountain working out another whole new formal system of something, right? Like, largely, maths is discovered/invented, and then a use is found for it. Sometimes maths is born out of necessity to describe something in physics or chemistry, but by and large, it stops being obviously relevant around year 9, and that can cause a drop in motivation to look at it for some people. So, like I said, it can be considered a kind of sport, a kind of thing that you do as a intellectual exercise or just for fun. Some maths is done for fun, some maths is done because it's satisfying to do, satisfying to prove things, and some maths is done because people really want to figure something out that's important to real life. And another thing that you should consider, especially if you've got a younger child or if you are a younger person yourself, for instance you're 7 or 8 looking at maths, you just gotta remember that it's not just numbers. Maths can be looked at in general as high-intensity logic training. So that's the point I wanted to make. It's logic training. It's not just about numbers. It's not just about practical application. It's about making sure that you can sort of be a master of this logical system that people have invented over the years for the purposes of doing something in real life or doing something for fun. So the next part I want to talk about is thinking deeply about simple things. And the content of this I took from a YouTube channel, Mr. Eddie Wu, who I think is a great maths educator online. And this question not only I think applies to maths, but it applies to anything you can see in life if you're trying to learn more about the world. The two questions, why and what if, and these two questions are, again, ideas taken from Mr. Wu's channel, can be asked again and again to make everyday situations mathematically interesting, or interesting from the perspective of other sciences. Why are longer passwords better? Because they're harder to guess. Why are they harder to guess? Because there are more possible passwords. Why are there more possible passwords? Because for every short password, an extra letter added on turns that one possibility into 26 possibilities from A to Z. What if passwords could only take 0 to 9? Then the situation is different. A password might have less possibilities. What are the consequences of that? Passwords are easier to guess. What does that mean? Your data is less safe if you just use 0 to 9 in a password. The point of that exercise was to demonstrate how even simple things like, oh, you should make your password longer. That piece of advice has a lot of maths behind it that can be found if you keep asking why something is true, and if you using what if to play with a particular situation and make it more interesting to yourself. Especially when talking to students younger than yourself, or talking to very small kids even, encouraging them to ask why something is true and use what if to play with a situation, put a situation into different conditions and make it more interesting, will encourage them to form good habits for understanding maths and physics by asking the same questions. The next thing I wanted to talk about is what I call learning by teaching, because that's what it is. But it was a technique that was written down, formalized, or some people would say invented by Richard Feynman. So it's also called the Feynman technique. When you want to understand a new thing, not just memorize the applications of that thing, not just learn how to solve every kind of possible problem that you would be asked to solve on an exam, but understand the rules beneath that enable you to solve those problems, or understand the rules such that you could apply those rules to new problems you've never seen before quite masterfully, which is what I consider understanding. If you want to understand something, you can check that you fully understand it by trying to teach it to someone else. So in a sense, I already do this with my maths channel, and I already do this with my YouTube in general, because I'm planning to use it not only for physics, which I've started doing, but also for chemistry and economics, two subjects that I also take at my IB level and want to confirm that I understand more, because these are subjects with more emphasis on understanding new concepts rather than memorizing information. Even though chemistry is probably the most memorize-y of those. You can check you fully understand it by teaching it to someone else, because when you stutter, when you stop and think, I don't know how to explain this, or I don't know how to talk about this, then you have identified that there's a gap in your understanding. So if you take some actor, like a puppet, or your infant sibling, or your younger brother, or like your stuffed toy, I have a stuffed panda that I use occasionally, then if you try and teach a particular concept to it that you need to understand, and these concepts are usually going to be listed out in some kind of exam syllabus, at least for the any people below undergraduate degrees, then if you try to explain it, you'll identify that gap in your understanding, and you'll be forced to think about it. And being forced to think about it is what will help you understand it in the long run, because by resolving all the logical inconsistencies that have piled up in your head while sort of learning new things, then you can gain this clearer and clearer image of what's really happening and why you solve certain problems the way that you are taught to. So I think this applies to all subjects as a learning tip, because a lot of basically every subject I can possibly think of has things that you need to understand how to apply to consider yourself someone who has learned the content. You keep figuring it out, and you keep teaching as you go along until you can teach the whole idea. This even applies to subjects that you may think are just raw memorization, because sure, things like biology or foreign languages, especially logographies, languages with pictorial words like Chinese, which is something that I do, are considered very memorization-heavy subjects by most people. But if you can understand the rules behind perhaps why certain Chinese characters are composed the way they are, or why things in biology are named what they are, or why cycles in biology happen that you need to memorize, or what the first principles or underlying ideas even are, because I know I had trouble with that. I personally don't take biology because of that. I thought it was very heavily memorization based, and it frustrated me. But lately I've learned more about it, and its first principles. But anyway, this just goes to show that the teaching by learning by teaching, is a very useful strategy, and it applies to more things than you might initially think. So the next thing I want to talk about going on from this, and it's kind of related, is that the problems worth solving are the problems you can't solve. In a problem-solving subject like maths and physics, and to some extent chemistry, if there is, for instance, a maths question that you could teach someone else how to do quite well, a maths question that you see it and you immediately know what direction you're going to take all the way through to the end of it, or maths problem that you have already seen in class and already solved before in a way that you could replicate that performance whenever you want, then fine, you understand it. So it is a waste of valuable time to continue working on that style of question. I see people sometimes taking math textbooks and attempting to do every single question within as a form of the grind, or a similar kind of studying process, right? But I disagree with this process because I think it's a waste of time to do maths questions that you already know how to do. If you can do every maths question in a textbook, and if you can teach how to do every maths question in a textbook, you don't need it. Because that textbook, or that section of a textbook, or even that page of the textbook is full of information that you already have in your head. It's full of words that are trying to teach a particular thing that you already have in good understanding in your head. And so the best way to spend your time if you're trying to become a better mathematician, a better physicist, a better chemist, is to work on the problems that you don't understand, because that's where new learning is done. To some extent, it is a way of procrastinating or saving yourself from the pain of dealing with topics you might not like or topics you might be bad at. But in reality, the most educational value is gotten from studying the ideas that are most difficult to you. So for instance, the subject of chemistry, I personally find things like redox reactions involving water and the ions of water to be an annoying topic. And so I should spend more time on it. When I'm studying, I will spend more time on it until I am confident that I understand it to the level that I could teach it to someone else. Because without that, I can't say that I've truly learned it. But, for instance, I find the specific heat capacity questions in chemistry absolutely trivial, because it's just an application of something I understand from physics, right? So it's a waste of time for me to continue working on those. It may make me feel more confident, it may make me feel more ready to tackle the test, but in reality, it's not helpful to me because I already understand them. I'm wasting my valuable time if I try and work on something that I already understand. So to round this off, this applies to maths and science in general. Spending 30 minutes learning how to do one new problem, one new type of maths, physics, or chemistry problem is more valuable than spending 30 minutes to do an old type of maths problem, a type of maths problem that you already know with a great amount of confidence, like 10 times. If you spend the 30 minutes doing 10 of those problems, you gain nothing. But if you spend it learning how to do one new problem, and you understand the underlying concept that you need to solve that problem, then that sticks with you. It's a permanent gain on your ability to do maths. So in application to maths and science in general, the problems worth solving are the problems you can't solve. So that's all I have to say for this video. I know it's quite short, but this is based on a text that I sent someone who I gave a school tour to a couple weeks ago. And so as I sort of had a script for this that I wanted to talk through. So anyway, until next time, which will be every Sunday at 6 p.m, I hope this video has helped you, and if it does, please subscribe and share the channel with your friends, and I'll see you later.